Hi, today's lesson is on mixtures. A mixture is formed when two substances are combined in a fixed ratio. Mixtures can be formed by adding sugar to water, salt to water. Those are called solutions. Or by mixing two metals, or even by mixing two different grains, or two different coffees of different brands to form a blend. But what is common to all mixtures is that two or more substances have been mixed in a fixed ratio. So the study of mixtures is essentially the study of ratio and proportion. A liter of water is evaporated from 5 liters of 8% sugar solution. Let's understand what 8% sugar solution means. It means in 100% of the solution, 8% is sugar and the rest is water. So 92% is water. If we were to write it as a ratio, sugar to water would be 8:92. Sugar to total would be 8:100. That is essentially what 8% sugar solution means. We have 5 liters of the solution. So let's find out how much is sugar. So sugar in 5 liters would be 8/100 times 5, which is equal to 0.4. So the amount of sugar in the 5 liters is 0.4. Now I evaporate 1 liter of the water. So what's the total volume now? The total volume now is equal to 5 liters minus 1 liter is equal to 4 liters. And the sugar is still 0.4. No sugar has been lost, only the water has evaporated. So what's the ratio of sugar now? Sugar is now 0.4/4, which is 0.1. which is equal to 10%. So now the solution has 10% sugar. The answer is C. How much water must be added to 75 quarts of 80% concentrated sulfuric acid to dilute the mixture to 50% concentrated sulfuric acid? So it's 80% concentrated sulfuric acid. That means 80 on 100 is the acid. That's the ratio of acid to the total. In 75 quarts, therefore, the amount of acid is 80/100 into 75, which is 4/5 into 75, which is 60 quarts. So 60 quarts is acid in that 75 quarts. The rest is water. Now we want to know how much water we should add. So now the concentration of acid becomes 50%. Well, that's easy. Acid is 60 quarts. You want this to be 50%. So the total should be 120 quarts, because 60/120 is equal to 50%. So totally we want 120 quarts of the solution. How many quarts do we have? Currently we have 75 quarts. We need to add water to reach 120 quarts. How much water? 120 minus 75. That's 45 quarts of water. The answer is B. What quantity of 60% hydrochloric acid solution should be mixed with 200 gallons of 30% hydrochloric acid solution to get a 40% acid solution? So let's say we have X gallons of 60% and we're given 200 gallons of 30% and we mix them and we finally get, how many gallons do we get? We get X plus 200 gallons of 40%. That's the scenario. We need to find X. So let's find out the actual amount of acid in each of them, because the acid in the X gallons of 60% plus the acid in the 200 gallons of 30% should be the total amount of acid in the 40% of X plus 200 gallons. So what's the acid? The acid is 60 over 100 of the X gallons plus 30 over 100 of the 200 gallons. That's the acid in the two original solutions. What's the acid in the mixture? Acid in the mixture is 40% of the volume of the mixture, which is X plus 200. Because you mixed X gallons and 200 gallons to get a total of X plus 200 gallons. Let's equate the acid, because the acid remains the same in both. Of course, the water also remains the same in both, but we just equate the acid. So 60 over 100 I can write as 3 over 5x plus 3 over 10 into 200 is equal to 2 over 5 x plus 200. I've just simplified the ratios. 3 over 5x plus 60 is equal to 2 over 5x plus 80. Therefore, 3 over 5x minus 2 over 5x is equal to 80 minus 60. 1/5 x is equal to 20. X is equal to 100. You need to add 100 gallons of 60% hydrochloric acid solution to the 200 gallons of 30% hydrochloric acid solution to get a final mixture of 40% acid solution. Let me show you a quicker way of doing this. So draw a number line. This is 30%. This is 60%. You can think of this as 3 over 10 and this is 6 over 10. So 40% would be somewhere here. 50% would be somewhere here. Now I'm taking some amount of 30% and some amount of 60%. And I want my final ratio to be 40%. So clearly I should take more of the 30% than the 60% because the final mixture is 40%, which is nearer the 30%. Suppose the final mixture was 45%, then obviously the ratio would be 1:1. I would take 200 gallons of this and 200 gallons of that to achieve the exact average, 45%. But now it's a weighted average and it's in favor of the 30% because 40% is closer to 30%. So, how much closer is it? Well, this is a distance of 1 and this is a distance of 2. So, it's 2 times closer to 30% than to 60%. So, I should take 2 times the amount of 30% as I should the 60%. So, the final ratio should be 2:1 of 30% to 60%. I know the 30% is 200, so the 60% works out to be 100. A very quick method of doing things. We just used inverse proportion. Since the distance from 30 to 40% is 1 and the distance from 40 to 60% is 2, the mixture should be in inverse proportion of that in terms of volume. Apple juice concentrate of type A costs 5 per pound and that of type B costs 5.8 per pound. In what ratio should one mix the concentrates of type A and type B so that the mixture costs 5.6 per pound? So I'm going to use the earlier technique. $5 per pound, $5.8 per pound, and we have 5.6 here. So again, clearly I should be taking more of type B, that is 5.8, than of type A, because the final mixture is much closer to B than to A. Let's see what the ratios are. This distance is 2 This distance is 6. 0.2 and 0.6. So the ratio is 3:1. So 5.6 is 3 away from 5 and 1 away from 5.8. So the ratio in which you should mix the substances should be A:B as 1:3. Well, the answer is not present. Let's make this 1:3. When 8 liters are removed from a 20% milk solution and 8 liters of water is added, the resulting solution has 16% milk in it. What was the initial quantity of the 20% milk solution? So I need to know the volume of the initial solution before I removed 8 liters of the solution and added 8 liters of water. So let's do it algebraically. Let's say there were X liters totally. So how much of it was milk? Well, milk was 20%. So the milk in it was 20 by 100 X, or 1/5 X was the amount of milk. Then I removed 8 liters. How much milk did I remove? Well, the milk will come out in the ratio in which there is milk. 1/5 of what is removed is milk and the rest of it is water, because you're removing the entire solution. So milk removed will be 1/5 of 8. That's 1.6 liters of milk was removed. So what's the milk remaining? The milk remaining is 1/5 X minus 1.6. Or let's just write it as X minus 8 over 5 liters remain. I've written 1.6 as 8 by 5. X minus 8 by 5 liters of milk remain. Of course, I add back water, so no milk goes back, only water goes back. And the final volume is again X. So this is the remaining milk in X liters totally. So we have X minus 8 upon 5 liters of milk remaining in a total of X liters of the solution. So what's the ratio of milk to the solution? It's X minus 8 over 5 upon X, which is X minus 8 over 5X. And this is given to be now 16%. So that can be written as 16 over 100. Let's simplify this. This is 4 over 25. Cross multiplying and solving for X, we will get 25X minus 200 is 20X, which will finally lead to X equal to 40. That means the original volume of the solution was 40 liters. That's the answer, 40 liters. You can check by checking the amount of milk initially, then take out 8 liters and check the amount of milk later. How much water must be evaporated from 300 gallons of 4% sugar solution to strengthen it to a 5% sugar solution? So in the earlier question, we were diluting it. We took out some part of the solution and we added water. So the concentration fell. Here we're going to heat it and evaporate just the water. So more sugar will be left with respect to the water and the concentration goes up. Let's see how we go about doing this. So let's first find the amount of sugar we have. So sugar is 4 over 100 into 300, which is the total, which is 12. So the amount of sugar is 12 in whatever units you want to measure it. Now the sugar still stays there, but I heat it and I evaporate the water. And finally now I have 5% sugar solution. That means this 12 is now 5%. So 12 is to X is 5 is to 100. 12 is now 5% of X. So let's solve for X. So X is 1200 by 5, which is 240. So the final volume of the mixture is 240 gallons. So how much do you need to evaporate? You need to come down from 300 to 240. So you need to evaporate 60 gallons. And that's your answer, E. "16 ounces of fresh orange juice contains 216 calories, and 16 ounces of fresh grapefruit juice contains 174 calories. If an 8-ounce mixture of the two juices contains 94 calories, what fraction of the mixture is orange juice?" Okay, first thing I have to be careful about is that I'm just taking 8 ounces of the mixture, while each of those are 16 ounces. So let's first find out what 16 ounces of the mixture will contain. 8 ounces contains 94 calories. Therefore, 16 ounces will contain 188 calories. Now that's the number I want to work with, because I'm mixing 16 ounces of orange and 16 ounces of grapefruit juice. So let's again apply our proportion method. Grapefruit, orange. Grapefruit has 174 calories, orange has 216 calories. So those are the two ends of my number line. And I want to know where 188 calories is. 188. So how far is 188 from 174? 14. How far is 188 from 216? 28. So the ratio is, it's 1:2. It's much nearer to grapefruit than to orange. So of course I mix the two in the inverse ratio. I mix it in the ratio of grapefruit is to orange, 2:1. So what fraction of the mixture is orange juice? Well, total is 3. And the mixture, whenever I mix grapefruit and orange in the ratio 2:1, I get a total of 3. The fraction of orange to total is 1:3, and that's the answer I'm looking for. A. The important thing here was that I had to get it up to 16 ounces of the mixture. I was comparing the calories in 16 ounces of each of the constituent juices. If two different solutions of alcohol with respective proportions of water to alcohol of 3:1 and 2:3. So I have solution 1 and it has water to alcohol in the ratio 3:1. So write this neater, solution 1. And solution 2 has water to alcohol in the ratio 2:3. That's the basic information. And now solution 1 and solution 2 are combined in equal proportion. What is the concentration of alcohol in the new solution? So basically, what's the ratio of water to alcohol in the new solution? And I'm combining them in equal proportions. That means if I take 1 of solution 1, I have to take 1 of solution 2. In 1 unit of solution 1 unit, how much is water and how much is alcohol? So water will be 3/4 and alcohol will be 1/4. In 1 unit of solution 2, water will be 2/5 and alcohol will be 3/5 because it's divided into 5 parts. Now if I combine them, I take 1 unit of solution 1 and 1 unit of solution 2. It's 1 unit plus 1 unit. That's what I'm supposed to do. I get 2 units. What's the total amount of water in these 2 units? Well, the total amount of water is 3/4 plus 2/5. What's the total amount of alcohol? It's 1/4 plus 3/5. What's the ratio? The ratio is 3/4 plus 2/5 is to 1/4 plus 3/5. That's the ratio of water to alcohol in a mixture of these two solutions where equal amounts of the solution were taken. Well, LCM is 20. I get 15 plus 8. LCM is 20. I get 5 plus 12. So that works out to 23 over 20 is to 17 over 20, which is a ratio of 23 is to 17. Water to alcohol in the mixture is in the ratio of 23 is to 17. They want the concentration of alcohol. So the total is 40. And they want the concentration of alcohol. That means they want alcohol is to total, which is 17 upon 40. as a percentage would be 17 fives are 85. 85 upon 2, which is 42.5%. C. The answer is C.